Night enveloped the desert above Heracleion. A group of archaeologists moved through the labyrinth of sunken ruins, illuminating their path with powerful flashlights. Suddenly, one of the researchers, Dr. Martin Hale, stopped in front of a temple wall. He carefully brushed away a layer of sand and discovered a strange bas-relief. A woman holding a creature with an unusually elongated head and enormous eyes. "This can't just be a stylized depiction of an infant," whispered his colleague, Alice Carter. "The Paracas skulls in Peru have similar shapes. Could this be evidence of hybrids?" The question remained unanswered, but the mystery of Heracleion continued to intrigue scientists. Theories ranged from ancient cults to contacts with extraterrestrial civilizations. However, biologists established that elongated skulls could be the result of artificial cranial deformation, a practice common in ancient times. No DNA analysis has shown traces of non-human genetics. Meanwhile, in another part of the solar system, the Viking 1 probe transmitted an image to Earth of a rock formation on Mars resembling a human face. The photograph instantly became a sensation, fueling conspiracy theories. "It's just pareidolia," astronomers stated. "The human brain is wired to recognize familiar shapes in random forms." Decades later, when NASA sent more advanced spacecraft, images confirmed that the face on Mars was merely an ordinary hill, with shadows creating the illusion of facial features. However, proponents of the ancient Martian civilization theory insist that the truth is being concealed. No less mysterious are the artifacts of the Maya civilization. Their bas-reliefs depicting beings resembling astronauts, their complex astronomical calculations, and myths of gods descending from the heavens suggest possible contact with extraterrestrials. Some researchers associate Kukulkan, the feathered serpent god, with alien beings. However, historians remind us that such imagery appears in many cultures and may carry purely symbolic meaning. In Scotland, on Arthur's Seat Hill, children stumbled upon 17 miniature wooden coffins with tiny figurines inside. The origin of these remains unresolved. Were they ritual offerings, connected to the murderers Burke and Hare, who sold their victims' bodies for medical research, or simply children's toys mistakenly perceived as something mystical? Some theories suggest they could have been a form of symbolic burial for souls who never received a proper grave. Others believe they were connected to an ancient superstition meant to ward off evil spirits. Another hypothesis suggests they were linked to an old Scottish practice of making talismans for protection against supernatural forces. The Antikythera mechanism found off the coast of Greece is another ancient enigma. This intricate device, over 2,000 years old, turned out to be an astronomical calculator ahead of its time. Studies revealed that the mechanism was used to calculate planetary movements and eclipses, proving the advanced knowledge of ancient Greek science. Many researchers now believe that similar devices might have existed, but no other examples have been discovered. Recent images from the Perseverance rover uncovered mysterious square structures on Mars. Geologists attribute them to natural crystallization and erosion processes, but UFO enthusiasts are convinced they are ruins of ancient constructions. The formations bear a striking resemblance to rectangular patterns seen in some ancient Earth structures, further fueling debates about potential past life on the Red Planet. In Germany, during excavations near Marburg Castle, students discovered a pocket sundial. The miniature device, several centuries old, amazed researchers with its precision and craftsmanship. Who owned it? Was it part of monastic heritage, used for prayers on a strict schedule? Experts believe that such sundials were rare and expensive, likely belonging to high-ranking individuals or scholars deeply engaged in astronomy and mathematics. Yet one of the most intriguing discoveries remains the Sabu disk, a 5,000-year-old artifact from Egypt. Its purpose remains debated. Some believe it was a ritual object, while others think it had a technical function, possibly part of an ancient machine. Some engineers speculate that its shape suggests it could have been part of a primitive flywheel or a component of an unknown mechanism. Certain studies suggest it could have been related to liquid movement or even served as a part of a lost mechanical system. Despite extensive research, its true function remains an enigma, adding to the ongoing fascination with the technological capabilities of early civilizations. The world is full of mysteries. Every solved enigma raises new questions. Were these artifacts merely the result of human ingenuity, or evidence of contact with forces we have yet to understand. As new discoveries emerge, the past continues to challenge our understanding, reminding us that history holds secrets waiting to be uncovered.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path. A white dwarf star, 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance.
We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars, it's just an empty, endless desert. Venus, only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of super liquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light-years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars' satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution and growth of a technologically advanced civilization. But just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small, well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, you'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation, which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name, too, the Fermi paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel, and the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there, picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So, the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it.
The universe is expanding, and if it's expanding, then it probably had a beginning somewhere. Now, all we have to do is to run time backward and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory. And here it is. Nothing has ever been anywhere, because neither when nor where existed. But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very, very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects in the world, stars. But what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. If we drop the balloon filled with paint down, it will burst. We'll see absolute chaos on the canvas. But the early universe don't look like. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Martin Boyovald is a German professor of physics, and in his opinion, the universe was born quite differently. According to Martin's theory, the singularity couldn't just appear out of nowhere. Let's look at a pendulum on the old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time doesn't work that way. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then, the Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Boyovald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. So for now, all this is just a hypothesis. But some people come up with even stranger ideas. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist. They say that yes, our universe isn't the first one. Our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until they finally collide. Their collision creates two big bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Which idea is closer to you? How about the idea of subscribing? Subscribe